Hey everyone, welcome to Practically. We bring learning alive, and we are going to do today 5 most important questions of physics. So the chapter right now we are taking is electricity. Okay. By the way, we have already covered a lot of other 5 most important questions. We are doing this series so that you people can understand completely all the chapters, which are the most important questions and which are the most probable questions. So if I'm writing this as most important, I can also say most probable. So if you practice these 5 questions multiplied by the number of chapters that you have got, that is around 35-40 in science and 35-40 in maths. So those questions will help you to understand and to get high numbers, right? So the target is to get full by full. Okay. So now let us come back. Let's do one first question. So the question number 1 says a current of 1 ampere. What's the current value? 1 ampere flows in a series circuit containing, what's the type of circuit? Series circuit. An electric lamp is there and a conductor of 5 ohm is there. So there are two devices. The first device that is there is an electric circuit having an electric lamp. So this is a resistor, by the way. So let me make a lamp. So there is a lamp and there is a resistor of 5 ohm. They are connected how? They are connected in series. And a current of 1 ampere is flowing through it. What's the battery connected? 10 volt. So quickly draw the circuit diagram. Now you will have 10 volt. You know that the total resistance in a series circuit is nothing but the sum of the resistance of each devices or each value. So the lamp, let us take the resistance is R. So the equivalent resistance Req is equal to nothing but R plus 5. Of course, ohm. Now apply your brain and solve that V is equal to IR as per Ohm's law. So voltage, potential difference is 10 volt. What is the current now? The current is 1 ampere times the resistance. So R plus 5. Simplifying, we get R is equal to 5. So the resistance of the lamp is also 5 ohm. Super. The resistance of the resistor is 5 ohm. The resistance of the lamp is 5 ohm. Now this question is solved. So part 1 is clear. Let's move to the next part. Now if a resistance of 10 ohm is connected in parallel. Now if a resistance of 10 ohm is connected in parallel with this series combination. So whatever you have got, I'm making a small one now. This is a lamp. I just made it in this way just to make you understand. And a new resistance of 10 ohm is connected in parallel with the same circuit. Have they changed anything? Let's read completely. What change, if any, through the 5 ohm conductor and potential difference across the lamp will take place? Simple, easy. This was 5 ohm, right? This was 5 ohm. This was 5 ohm. This is 10 ohm parallel, right? So what is the equivalent of this whole combination? 5 ohm. How? See, very simple, okay? The series combination is 10 and again it is connected in parallel by a 10. So 10 and 10 parallel is nothing but 5. We all know this. So we got 5 as the equivalent resistance. So the net current which is going to flow, since the battery is 10 volt, the net current, the new current, I new, which is flowing through the complete circuit, the I new is nothing but 10 by 5, which is equal to 2 ampere. You know, since the current which is flowing right now through this whole circuit this is 2 ampere, the moment it reaches, it has to break. If the resistance are equal, the current will split equally. You can also apply whatever V is equal to IR and find, don't waste your time. The current will split equally. So what will happen now is 1 ampere will go inside this and 1 ampere will go inside this. Now both will receive 1 ampere each because the current now is getting out to be 2 ampere. Now this means the current flowing through the 5 ohm conductor remains the same. The 5 ohm is still getting the same 1 ampere. Previously also it was getting same 1 ampere. Nothing has changed. Now it is asking what is the potential difference across the lamp. So potential difference across the lamp is still the same. The reason is because it's still the same 1 ampere current is flowing in the lamp. Nothing has changed, and this way this whole thing will remain the same if nothing has been done wrong. Right. Fine. Okay. So this is what it is written. Potential difference is still the same. It will still be the 5 volt. Okay. And voltage across 10 whatsoever. We have already solved it. Okay. Let's move. Define 1 volt. You all know what's 1 volt. When you know V is equal to IR. What is 1 volt? 1 volt is nothing but when a 1 ampere current flows through a resistance of 1 ohm. When a 1 ampere current flows through a resistor of 1 ohm. Fine. Okay. Express in terms SI unit of work and charge, and calculate the amount of energy consumed in carrying a charge of 1 coulomb. See, there can be two definitions. The first definition was based on the 1 ampere, 1 current and 1 ohm. But let's say you want to term in terms of this. Do you know voltage is nothing but work done per unit charge, right? Erase it. Or W is equal to QB, right? So 1 volt or 1 amount of potential difference is done when 1 coulomb charge is drawn from infinity to a point and 1 joule work is done. How much joule work is done? When 1 joule of work is done to bring a 1 coulomb charge from infinity to a point, the potential at that point is nothing but 1 volt. This is also the definition for 1 volt. Now we have to find the SI unit of work we know is joule and charge is coulomb. So what is 1 volt? It is 1 joule per coulomb. 1 joule per coulomb. Okay. And you have to find the energy, which is nothing but you have to find the W. So 3 volts. So W is nothing but QV. So Q is what? You are getting 1 coulomb charge. So 1 coulomb multiplied by a battery of 3. So it will be 3 volt. So total energy is nothing but, 3 joule. The total energy is nothing but joule. Okay. Fine, we got it. Okay, let's move to the next one. What is electrical resistivity? It is the property of a material, right? It is the property of a material denoted by the symbol rho. Rho is independent of the length and the area. Rho is depending on the type of the material. Okay? So rho in general, it depends on temperature. Rho is equal to rho naught 1 plus alpha T, where T is the temperature and alpha is the temperature coefficient. I don't know if this is taught in your syllabus, but generally rho, the specific resistance or resistivity, whatever you call it, is a material dependent thing. If you change the material type, resistivity will change. For the same length of wire, same cross-sectional area of 2 given wires, the resistivity will be different and therefore the resistance. That's why the resistance are different. Okay. So, and in general, R is equal to rho L by A. So the resistivity equals the resistance for 1 meter length of the wire with 1 meter square cross-sectional area. Then rho is nothing but ohm. Then this will cancel meter. So this unit of rho, the unit of resistivity is nothing but ohm meter. So resistivity in general is nothing but equivalent to the 1 ohm resistance of a wire having 1 meter length and 1 meter square cross-sectional area. Fine. So this way you get the resistivity also. Okay, the unit of resistivity. Now what it is asking us, in a series electrical circuit comprising a resistor made of a metallic wire, the ammeter reads 5 ampere. So there is a resistor and the ammeter is telling you that it is 5 ampere. Some resistance R. Okay. Now the reading of the ammeter decreases to half when the length of the wire is doubled. Why? Simple thing. When you take a wire of given length L and a cross-sectional area A, if you make the wire as double, that is 2L, what happens to the area? Apply your brain. The volume can never change. The volume is constant. The volume is constant. This simply means that initial volume is equal to final volume. So the initial volume is nothing but area times length. Pi r square h is the unit of, yes, the area volume formula for cylinder. Wire is generally considered to be cylinder. So area into length. So A1 L1 will be equal to A2 L2. If I am saying the new length is double of the original length, so this means that L1 will get cancelled. So the area, the old area or the new area you can say, is nothing but half of the original area. So the area becomes half. The wire will become thin because the volume hasn't changed. So basically when you stretch the wire to double the length, the wire will become thin. Now this simply means that the net effect on the resistance, what is resistance? Rho L by A. Rho L by A, right? So it is saying the reading of the emitter decreases to half. Let's find out. The resistivity of the wire will not change because I told you it's a material property and does not depend on length or area. It is a material property. It's a constant on material, type of material. It depends on temperature though, but we are not talking about it. So we keep the same rho. So, but now what has happened? The length has become double twice. And what has happened to the area? The area has become half. So it has become A1 by 2. Right? You got it? So this simply means that this is rho. This will become 4 L1 by A1. Fine. Okay. Now, if, listen very carefully, this is a very good question to understand all and clear all the concepts. If I take the same wire and I make it double the length, if I take the same wire and make it double the length, the area will become half, the length will become double. The new resistance R2 is nothing but 4 times the original resistance, rho L by A, right? So the new resistance is 4 times the original resistance. This means the current should become reduced 4 times because current for the same potential is inversely proportional to the resistance. The higher the resistance, the lower the current. Since the resistance has become 4 times, the current should decrease 4 times. But what has happened is ammeter has decreased to half. This means that in this question, listen carefully, they have taken a new wire with the same cross-sectional area. This you have to understand. If this question would have been framed in such a way, this way you can say the wire is new. So they have taken a same wire with double the length without changing the cross-sectional area. So they have taken a new wire. It is not the same wire. They have taken a new wire. So this simply implies now that the resistance, since is going to be just half, because doubling the length will double the resistance and the current will be halved. Doubling the length will double the resistance, so the net current will be half. So that's why the ammeter is showing half. The length of the wire is doubled. This means that because the resistance has doubled, resistance has become 2L, the area hasn't changed. If the wire was same, the net resistance would have become 4 times, the current would have reduced 4 times, right? Okay. Let's move to the next one. 3 incandescent bulbs of 100 watt each are connected in series in an electric circuit. So there are 3 bulbs. I have to connect them in parallel and in series, okay? Parallel and series. This is my parallel combination and I'm just doing it quickly because you people understand, and fine. Now, there are 3 bulbs connected in series and in parallel. Fine. Will the bulb in the 2 circuit glow with the same brightness? No. Understand the reason. The net resistance here, R equivalent, is R plus R plus R, which is nothing but 3R, considering they are the same bulb of same watt. I am considering they have the same resistance also. So this means that the net resistance now, what will be the new resistance? The net resistance, it will be 3R. Now, when they are connected in parallel, the net resistance has to be calculated this way. This simply means it will become 3 by R, but it is 1 by Req. So in this case, the net resistance is R by 3. So the net resistance has reduced by 3. Hey Ashray, good afternoon beta. So the net resistance has been reduced by 3, divided by 3 times decrease, okay? While here it has become 3 times more. More resistance, low current. Low resistance, high current, because current and voltage resistance have inverse relationship. Okay. Now this simply means that this bulb will glow little faint because they are getting less current. High current will glow, low current not dim. So will the bulb will same brightness? No, because the net resistance is high, the current will be low. So I will be 1 by 3 of I2, or I can say I in series will be 1 by 3 of I in parallel. So the series combination current will be 1 by 3 of, sample paper in English will start from, we'll do it not now, we'll do it after the, once before the board exams, very close, okay, then we will do it, don't worry Ashray. So I sample 1 by 3, I series will be 1 by 3 of the I parallel, the parallel current divided by 3, because series will be lesser current, okay. Now let one bulb in both the circuits get fused. Let's say this bulb is gone, boom. So bulb is gone, boom. The problem now is in series one bulb is gone, the circuit is incomplete. It becomes open circuit and no current. No current means all bulbs will switch off. But in parallel, it doesn't matter. When one blows away, the other two will still receive the current. But now the current will change, of course. It has to change. But the bulb will continue to glow. Will continue to glow. In parallel, yes. In series, no. In parallel, yes. In series, no. Everything is written here, beta. You can always take the reference. Okay. Yeah, done. Last question. Only 5 questions we are doing. This is the last question. The VI graph is shown, super, of for 2 wires A and B. If both wires are of same length and same thickness. So I've got 2 wires. They are same length and they have same thickness, means same cross-sectional area. Fine. Same length, same cross-sectional area. Which of the two is made of a material of high resistivity? Come here. Read this. This is the most important problem for your exam. I am telling you, you will find this kind of problem for sure. From graph, can you explore, can you understand the relation between resistance? Let's apply the brain, okay? I see the VI graph. I know the resistance is nothing but V by I. Right, ho? Right, so now I see the resistance is V by I. I take a value here. Okay. And I take a value here. For same this thing. So this is my V2 or VA. This is my, so my IA and IB are equal. I want you to understand something very quickly. Your brain will work very fast then. This is my VB. So this is my VB and that's my VA. Understand the complete detail. This is my VA. For the same, IA is equal to IB. IA and IB are same. Both have this at any one instance of current. I am seeing 2 different values of voltages. Right? VA and VB. Now, we can see that, no, this is not visible. We can see that VA is greater than VB. Right? But IA is equal to IB. So if I write RA is what? VA by IA. And what is RB? It is VB by IB. Now you see what I have done. When denominators are same, that is at the same value of current, IA is equal to IB, RA is proportional to VA and RB is proportional to VB. Considering these two are same, I have removed it to bring proportionality. Now I can see if VA is greater than VB, RA is greater than VB because of this. Because of VA greater than VB in the graph, RA is greater than RB. RA is greater than RB. How can resistance be greater if I have the same length, the same cross-sectional area? I know by the formula level that R is equal to rho L by A. R is equal to rho L by A. The moment I say R is equal to rho L by A, what I say one more step is R is proportional to rho for the same length and same area of cross section. This simply means that, this simply means that rho A is greater than rho B. Because when RA is greater than RB, then rho A is greater than rho B, since L and A are same. So I can say rho A is greater than rho B. So which is the material of high resistivity? Rho A. The wire A is the material of high resistivity. Simple logic. Okay. So I same. VA is greater than VB. On the graph I can read it. VA is greater than VB means RA is greater than RB. RA greater than RB. R is equal to rho L by A. L and A are same. Both the wires are of same length, same cross sectional area. So resistivity is proportional to resistance. So this simply means that if resistance of A is greater than, it means the resistivity of the wire is also very high compared to the resistivity of B. Okay. So you can always rho A is equal to rho B. This is what your final answer is, the green one. Got it? I hope you have got it. That's why the most important question, and you have to play in the same way. You have to write all the reasons stating that this is why you are doing it, because of these situations popping in. Okay. They will give you this kind of graph and can ask you anything about the resistivity, and they can even ask you about something else. Okay. Fine. Cool. So next class, remember every day we are doing it at 12 p.m. If you are not aware, 12 noon or 12 p.m. and 1 p.m. This is your math class always. This is your science class. So science is happening like some chemistry, bio, physics. Okay. Today it was physics, right? So we are covering all the chapters. We are not going to cover that our environment, and we are not going to cover one more chapter somewhere. Okay. But most of the chapters we are going to cover. So every day 5 most important questions, just this. Get this right and you will get sorted by science and math. Full 40 by 40 numbers. Enjoy your life. Okay. Till then, keep subscribing. If you haven't subscribed, subscribe the channel, like the videos. And all this is available on app. There is a tile in the app. Download Practically app. Go to that page, enroll, get the PDF of this and get the video recording. Right there in the same one single place. Okay. Sample paper 3 we didn't do because we saw that most of the people were not like getting that much. So we thought let's shift it. We didn't cancel it. We thought let's shift it to the before the board exam. So we'll take it there right away. I'll take that sample paper 3 right there. Okay. Don't worry about it. Fine. Okay, Ashray. Okay, everyone. We'll see you in the next class. Thank you.